So now over to Sergio, and Sergio is going to be talking about libRIST 020, talking about a lot of new features that are coming and giving us a little bit of a demo of how things work. So Sergio, over to you.
I'm Sergio Ammirata from SipRadius, and today's talk, in today's talk, we'll look at the recent release of libRIST version 0.2. So the focus of the discussion will be about what's new. 0.2 has the usual batch of fixes. It also has a few important enhancements. We'll view libRIST overall functionality in a demo, which will be the final part of the presentation. We'll use network emulation to create a very loose network condition between two machines, and that will allow us to see the robustness and efficiency of libRIST in real time. But just as importantly, this release brings with it a degree of maturity that may surprise a lot of people. It's not just robust and efficient. It has a characteristic that warrants its inclusion in the standard media toolset that comes with Linux and other platforms. We'll be discussing that in the presentation too. Okay, next. All right, so before we begin, we should mention that this library has truly a 7-year history, right? It started as a patented commercial offering that was codenamed Dozer back in 2014. For 5 years, this code base and the algorithms associated with this for retransmission and congestion control were perfected and field proven with hundreds of real deployments that are still in use today of live transmission, television channels, etc. Early last year, the code was basically modified to be Rist compliant and released as the first version of the libRIST open source project. Like was mentioned, is BSD type 2, very liberal license. For the next 12 months after that, the open source for the Rist library was field tested and optimized for cross-platform and cloud use by a number of developers from many different parts. There was a very large community engagement in the upgrade of the code base, as you can see by the number of commits in only 1 year, 750 or so. Let's look at the fixes. I'll pause for a moment to let you read the bullets. A lot of these fixes have to do with efficiency because the core identity of libRIST is multi-stream, multi-path transport. We concentrate on efficiency in network and CPU usage. And the secondary focus of the fixes in this release has been to make sure that we have proper cross-platform support. The main new features on 0.2 are in the areas of security, cross-platform performance, and jitter control. The security model gets a lot of our attention because we expect that people have a lot invested in the streams that use protocols like this, right? So our we added authentication based on the latest spec to cover that. Our cross-compile support now reaches 18 platforms. Pretty much everywhere where VLC compiles, we're tagging along and we're making sure that our library compiles as well. And we'll spend a little bit of time on the jitter prevention enhancements in the next few slides as well. As we mentioned, we put a lot of focus on network efficiency. One of the things we've learned over the years of doing error correction protocols is to step back and not contribute further when the network is already congested, right? Sending a lot of re-requests for drop packets is just shooting yourself in the foot if there are network problems. So we have timers that hold off re-request. We don't send re-request after the buffer time has expired if we see adverse conditions, plus other things to not make a bad situation worse. Now, given a sizable buffer, we see libRIST as making streams viewable even in conditions of 60 or 65% packet loss in our lab tests. It's hard to reproduce that type of packet loss in a real line out there. Now, related to adverse condition, we've added several timestamping behaviors in version 0.2 as well. These behaviors ensure a measured release of the stream to the output without jitter. We also measured the new authentication model, right? With previous releases, we already had AES encryption. But encryption only goes so far if the gatekeeper lets everyone in, right? So taking SRP and EAP as inspiration and specifically adapting the step-by-step challenge response methods of the two to a UDP connection, I think we built something that is really secure, and it has to be. What libRIST can do in main profile is to put the sender in a one-to-many promiscuous listening mode. It binds to a listening port, and as many receivers and as the bandwidth and processor can support can receive from it, like the media server model. So given the low CPU usage of libRIST compared to other error correction protocols, you might find that bandwidth rather than CPU will be the limiting factor when you do a deployment with this. We've included what we call an SRT password utility. If you used HT password from Apache in the past, you'll have some idea on how it works. We followed that model pretty much. Each side offers a public key for verification over already an encrypted connection. So this is a robust security model. Before we talk about the future of libRIST, let's review where we stand. The key takeaway I want you to have is that its robust ability to transport multiple streams over multiple paths. If you write to the library, you have no limit. You can implement however many connections as you want. If you use the utilities we provide, the executables, with the command lines, you can specify up to 20 RTP or UDP streams input or output on either side, and up to 10 peers on the multipath connection itself. The tools provide load balancing and weighting of the different paths. They give you redundancy, split path, however you want to configure it. That has been there since 0.1, the first release of the library. And with some of the network efficiencies in 0.2, they're even better now. So before we move into the demo itself, let's take a very quick look at what's coming next for the library. It looks like libRIST is going to find its place in the distros and important media software. We've been included in the FreeBSD ports. We're already in the main code base of FFmpeg. I believe 4.4 will have it. We're in the final stages of committing support for VLC 4.0. Whenever that will be released, can be much longer for that. And we're awaiting word, but we expect to be included also in the Debian repos. We're definitely coming along well. So now let's go ahead and move to our demo portion. Okay, our demo portion is going to be quite a simple, straightforward demos. We have 2 machines and a network emulator in between that will let us fine-tune packet loss between the 2 machines. In the first machine, we're going to go ahead and start FFmpeg and stream a video on a loop. We're going to feed that video to the Rist sender command line utility on the same machine. And then we're going to receive it on the second machine and stream that video back to my laptop where I'm going to show it on the screen. Okay. So let me go ahead and switch to that. When I open a console. All right, you can see here, it's kind of small, but I have 3 tabs. The first 2 tabs are on the first machine, and the third tab is on a second machine. Those are just SSH connections to the machines in question. Next, I have a web page connected to our emulator user interface. So let's go ahead and start this demo portion. All right, so we'll start inside a console. on what will be our sender. The first thing I want to do is to create a password file. Okay, so I'm going to go ahead and show you a little script that I use to create a password file, because part of this demo is going to be demonstrating the new security mode. So I'm going to go ahead and copy and paste, and I hope you can see that if it's not too small. There's a little script here that executes the utility Rist SRP password multiple times with username and password, and each time it adds a line to our password file. Okay. If you're familiar with Apache's HT password utility, it's something along those lines. So we're going to use this script to generate about 20 users. Okay. So now I'm going to just run that script here. Okay, the password file has been created. Let me go ahead and show it to you. It's this big mess, just one line per user, the username, and then SHA-256 hash of the password itself. We never store the password in the clear. It's a one-way hash, and that's very well documented in the algorithm itself. We're going to make this demo sort of like a group exercise. We're going to allow viewers to connect directly to the Rist streams if they want to. If you have a libRIST compiler handy, it's a short notice, but you can just open the streams yourself once we start. So we have a 1080p video. The sender will go into receive mode, meaning listening mode, on a port connected to a network emulator. Then there will be a receiver connected on the other side, and then we'll start increasing the packet loss to severe levels using emulation till we see some lost packets. That's the gist of the demo, to show how robust the library is in adverse network conditions. For the audience participation, for those who have libRIST ready, the sender will listen at the same time to an external port, and you can use the public IP to connect to it. We'll post the link in the chat if anybody wants to open it up. All right, so let's go ahead. I'm going to go ahead and start the stream, the FFmpeg live video output. And I didn't start my timer, so if somebody else can warn me when we're about 5 or 10 minutes away, I would appreciate it. All right, so I've started FFmpeg. I'm just streaming a local video on a loop to the same machine, the internal adapter 127.0.0.1. That's all I'm doing for now, right? Now I'm going to go ahead and start this sender. I'm going to go ahead and copy and paste, but not start it, so I can do a brief explanation of what I'm doing. All right, so I've copied and pasted a Rist sender command line. It's reading from the UDP that is being created by FFmpeg. And then I'm creating the output itself to listeners on both the public IP of the machine and the second interface, a second listener that is going through the emulator, so that I can have the choice to go ahead and retrieve the stream with and without packet loss to see the difference and to run more tests. So that this is all it's doing. It's one input and two listeners, both two outputs, both in listener mode. So I'm going to go ahead and start that one. So for those who are familiar, -I is for input, -O is for output. Okay, I've set up some parameters here. They're very close to the standards on the library as far as buffer size, 1 second, a reorder buffer of 25 milliseconds, put some boundaries in the RTT that it will measure, even though it's dynamic. Our network emulator by default, I believe, has 70 milliseconds in either direction. So it's a 35 millisecond round trip, which represents pretty much any connection out there. So let's go ahead now and look at their receiver. I'm going to switch to the other tab and make the other machine that's in the other side of the network emulation. It's going to initiate a connection to the sender. So I have the Rist receiver with -I connected to the other machine. And then the output of this one, if you look at it here, the output is just going to my laptop across the internet on port 8300. Actually, I'm cheating because I'm in the same data center. So the connection from the Rist receiver to me is a solid, local area network, but that's fine since I'm using UDP. I want it to be a solid, connection with no packet loss. I want the packet loss to be only between Rist sender and Rist receiver. And you'll notice that I'm using the IP address that goes through the network emulator. There's another IP address that the sender is listening to, which people from the outside can connect now and run this test in parallel using their own connection and see how it behaves across the internet, viewing the packet loss that goes through it. So I'm going to go ahead and start this guy. We see that it connects with authentication. There's the log. And then it starts spinning the messages once per second. This is, I'm going to spend a few seconds here. Typically, people are confused about what the stats tell them and the fact that they reset. The stats, they have two different groups. One of them shows the cumulative stats since you started the service, and it only shows very brief cumulative information: total packets received, total packets recovered, and lost packets, if any, since the start of the connection. You'll see that repeated every second. It prints the cumulative stats. But then the bulk of the stats, everything else you see there that is 20 or 30 parameters, they are the average of what happened or the cumulative stats, but only for the last second. And then they reset, and then you get another average for the next second, and so on and so forth. So when you write your application, you can capture that, those stats every second and build a graph over time of a lot of parameters. But if you don't want to capture it, you can have the cumulative stats for the very basic, most important information, which includes the total number of packet loss since the beginning of the service itself. And we see here that it says 0, as expected, right? Let's look at the output of that. It's going to my machine, so I'm going to go ahead and have my VLC listening in port 8300, and I just started it. Okay, now Zoom is only 12 frames per second, I think, or so, if you're lucky. So the video itself is 30 frames per second. You won't be able to appreciate it very much, but the point is, it plays normally. There's no packet loss, right? When you receive it, if you want to do it over your own internet connections with the link that we gave you, you can see it full screen with your own machine. And we have somebody standing by. They're going to copy and paste the command lines into the chat for you. All right. So now let's switch to the emulator itself, which is the last component on the demo. So here's the GUI of the emulator. This is our proprietary hardware. It's a nice little 6-port fanless i7 mini PC. We also have a 1U and a 4-port emulator as well, smaller, that we use for our own testing of links. We're going to start with a 1% packet loss, which is what you see here. And there's 17 milliseconds on each side. You see delay 17 milliseconds. This connect line 2 and line 3 are the ones that form the bridge for this connection. I'm only going to be changing the packet loss in one direction. But we have the delay of 17 milliseconds in both sides to simulate a true internet link. All right. Okay. In our case, we chose 17 milliseconds because it mimics a New York to Los Angeles transit in a very good network, in very good network conditions. So let's flip to the sender console. If you can read this over Zoom, and we'll see that the sender itself is going to report the number of retransmission. The quality at 1% packet loss, we see the quality of the links reported by the tool. We see send 240, retransmitted 3, right? So there's a small percentage of retransmissions as expected every second. And on the receiver, on the stats, we see that those are all recovered and the cumulative loss remain at 0. You can see the cumulative stats right here, recovered 710 since we started, lost 0. And then if we do the analysis by the second, then we see what's happening there. And here's the video. So now we're just going to go ahead and increase that to 10% packet loss, all in one shot. Oops. 10% packet loss, apply. Now, the reason we know this actually did something is because we can immediately see in the stats running through the screen here on the bottom that the quality dropped to 90 as expected with 10% packet loss. We see received 329, missing 38. All of them are being recovered. Still, the cumulative loss is 0. And you can see the video on your screen still doesn't have any issues whatsoever since there's 0 packet loss. So let's go ahead and go to 20. Now we have 20% packet loss. There was a small glitch during transition and we lost 1 packet when we reset the variables. Through VLC off here. We can see the event that we saw on the video itself. We can see how it affected. Just 1 packet loss can affect a receiver, which is what we saw here when we switched to 20% packet loss. So we can see that the stream is still holding strong. And we can go all the way up to 50 and see how it still has no issues recovering from the stream.
So what are you restarting, Sergio?
I'm restarting. Apparently we had a small problem with the sender. It had a crash. I guess we need to report a bug to the library.
Oh, okay.
So something happened and we had a crash on the sender.
I can make an introduction to the guy who wrote it.
Yeah. Yeah, I don't know what they were thinking, huh? All right. So you get the gist, it's all the way to 50. Authentication works, everything else works. So I don't know how much time it has. I forgot to start my...
You got about 5 minutes, Sergio.
Okay, perfect. I want to leave a little bit for Q&A, but okay, the stream is back up and running, 10% packet loss, and the video's on. So now let's go back here. I'm going to go straight to 50 and then conclude it there so I can have a Q&A.
Oh, I think it's a simple question. He's asking, what is the official link to the libRIST repository? You can. Do you want to put the answer into the Q&A, Sergio?
Yeah, here, have it here. It's actually an ecosystem. The library itself is part of the ecosystem. The ecosystem includes wrappers to use the libraries in different languages. So you have the library, libRIST, and then you have the library wrapper for Rust, for Python, for C++. We have a Wireshark plugin, etc. So I'll just put it on the chat.
Okay, yeah. Monty, if you indulge us, we'll do that after Sergio is done. He can do that while he gets a sip of his coffee and can relax a bit. So question I had for you, Sergio, you were showing us some performance numbers and things like that. Would you say that the buffers that you use are typical or extreme, or what did you need to, how did you configure your buffers in order to get the performance we were seeing?
We have the library itself has some defaults, and those are pretty much the ones I'm using now. I mean, very, very close to the defaults. I believe we only changed the max RTT so that it wouldn't go too far above a certain value. But we made sure the library itself was fine-tuned, the parameters inside and the default values for the sweet spot. Sweet spot in the library point of view is from 0 to 1 gigabits per second as far as the amount of bandwidth it can handle. And from 0 to 60 or 65% packet loss without any problems. We can do that with a 1 second buffer. If the round trip time is within reason, right? Like the ones I'm showing here, 30 to 50 millisecond round trip. That's with a 1 second buffer. You can navigate through that sweet spot without any problems, without changing any parameter. And that's important because when they include the library in other tools like FFmpeg and VLC, most likely people will not tweak those parameters when they use it.
Right. So if somebody was to tweak the parameters, do you have any feel for what kind of packet loss you might be able to tolerate if you were, let's say, sending a 5 gigabit or a 10 gigabit signal?
Well, for the higher bit rates above 1 gigabit, it's not only parameters you have to tweak. You have to actually compile the library and tweak some of the internal constants for the library to react faster, etc. And even in such case, I believe for the higher bit rates, realistically, you cannot get to the high levels we get right now.
Yeah, you're probably not going to get to 50% packet loss.
No. I mean, my guess is that 10 to 20% will be, the sweet spot when you go above 1 gigabits per second up to 5 or 10 or whatever it is.
Yeah, sure, that makes sense. But the good news is that all those tools and tweaks and handles are all available in the code, right?
Correct. It's all open source. It's documented. We need to do a little bit more on documentation, but it's good enough for anybody to implement it directly, like a lot of people have done, a lot of companies, or use the tools if that's the way you want to do it. You can do that as well. The tools and the library are both BSD Type 2, so you can use them both in your projects.
Great. And so about how many people do you think are contributing to libRIST right now? Have you?
Last time I checked, we had at least 15 to 20 active developers that in one time or another have contributed to the code. One of the important things is that we see a lot of company sponsored contributions. We have people from
That's great.
We have people from the companies that have an interest that use the library themselves. They actually make a point to contribute back. They put time, pay some of the developers to help us out or to report bug fixes as merge requests, which means they not only take the time to report the bug, they actually fix it and send us the code to merge it, which actually gives them, puts their name in the library, and the library being, at this point, mostly for companies to integrate. If somebody contributes to the library, we are allowed to put their company name as part of the, one of the contributors. So it's a little bit of free marketing that they get for prosperity, having the company name as part of the code base.
Well, that's great. Little path to fame, I guess, huh?
Yep.
All right, great. Anybody else have any questions?
It was a great presentation. One final question. Is there any discussion channel, place to post questions?
We do. We have a Slack channel that is the main Rist channel. We hijacked it to be a libRIST as well. The official one is a Telegram channel called libRIST_developers. That's where the core developers just chat and argue and debate about
argue.
So it's good to have people that don't think like you. Otherwise,
absolutely,
you'd make a big mess. I'd make a big mess, if I didn't have the other people stopping me from adding everything I can think of.
Well, that's great. Sergio, thank you very much. That was really, really interesting. And if you want to stay on a little bit and maybe if you have any resources you want to share in the chat window,
I'll go ahead and
Q&A window, we'd love to have you do that.